Hi there, this is Mr. Bainey, and this lesson is 9.4, Algebraic Representations of Transformations. So this lesson sort of goes along with the first three lessons in that we're going to look at the rules for all of the transformations that you've seen so far, and that's translations, reflections, and rotations, right? Or the common words for those would be slides, turns, and flips. So if you don't know what the transformations are and how they work, it's probably a good idea to go back and try to understand those first. Watch those videos before you attempt to watch this one, because there's not going to be a whole lot of visuals here. We're going to be working mainly with the numbers. So our standard up at the top right is 8.G.3. And our essential question, how can you describe the effect of a translation, rotation, or reflection on the coordinates using an algebraic representation? So algebraic just means we're going to be using some variables here. So first, we're going to look at translations. And with each of these transformations, we're going to be looking at, I'm going to talk about how the rule works, and then we're going to try to apply it to the your turn. If it seems like it makes some sense to you, you can try the your turns before I actually give you the solution and go over it if you want to see if it makes sense to you. So, translations. So remember that translation is a slide. We can describe translations by going up, down, or left or right, or up or down, or left or right. So think about this. If we're going to the right or to the left or the left is going to be affecting the x, right? So the right or the left is going to be adding or subtracting to the x coordinate, and then if we're going up or down, that's going to be affecting our y coordinate. Okay, so this example right here, although I'm not going to go over it, it's a good one to look over if you wanted to just see an extra example. But let's go to the your turn. Okay, number one, a rectangle has vertices 0, -2, 0, 3, 3, -2, and 3, 3. So the first thing before I continue is you should know how to plot these points on a graph. Okay, so if you are having trouble with understanding this and how it works with just the points itself, go ahead and graph it, do the translation, and then see what you end up with. Okay, it's a good way to learn how to deal with these numbers. So what are the coordinates of the vertices of the image, right? Image means our new figure. After the translation of x comma y transforms to x minus y comma y minus 3. So one thing you need to understand about these rules is that x comma y always means the preimage. And then x minus 6 and y minus 3, that always means the image. Okay, this arrow that's in between means we're going to transform it. Right, we're taking all of these points here and we're transforming them. So I'm going to write these points in blue. So I have 0, -2, 0, 3, and 3, -2, and then 3, 3. Then I'm going to go ahead and let's see, apply this rule. So this, I'm going to take the x. Let's see, I'm going to take the x coordinate and I'm going to subtract 6. Okay. Then I'm going to take the y coordinate and I'm going to subtract 3. So we're doing a couple different things here. So I want to take the x coordinate, that's 0, and subtract 6. And then I'm going to take the y coordinate, which is -2, and I'm going to subtract 3. So here's another thing. If you're not sure how to subtract these integers, you're going to be in a little bit of trouble as well. So my second point is 0, right? I'm going to subtract 6, remember? And then 3 is my y coordinate. I'm going to subtract 3. Okay, that one's a little easy to do. Then the third point is taking my x coordinate, subtracting 6, my y coordinate, -2, subtracting 3. And then the last point is 3 minus 6, and then the y coordinate 3 minus 3. So notice my x coordinates are 0, 0, 3, and 3, and I have those are all right here. I'm subtracting 6 from all of them. And then here's my y coordinates here. You'll see them right after the comma. I'm subtracting 3 from all of those. Okay, so this is what I end up with when I subtract them. My first point is negative 6, negative 5. My second point, 0 minus 6 is negative 6. 3 minus 3 is 0. Then 3 minus 6 is negative 3. Negative 2 minus 3 is negative 5. And lastly, I get negative 3 comma 0. So these are my points of my image after the translation. And that is it. Let's look at reflections. So we've, in 9.2, only talked about 2 different types of reflections. You can reflect it over the x-axis. Remember that it's the one going left to right, and you treat that as like your mirror, where everything's going to be the same on both sides of that mirror. You can also reflect it across the y-axis. So the rules that you see across the x-axis, you get, it actually tells you right here, multiply each y coordinate by negative 1. All that means is you just change the sign, right? So if it's positive, it becomes negative. If it's negative, it becomes positive. So our rule is x comma y transforms to x comma negative y. So the negative y just means let's change that sign. And then if you reflect it across the y-axis, the x changes, right? X comma y becomes negative x comma y. So this is how I remember it. You can remember it however you like. But across the x-axis, the y changes. Across the y-axis, the x changes. Okay, x-axis, y changes. Y-axis, x changes. Okay, let's take a look at the your turn. Number 2. Triangle ABC has vertices of A, which is negative 2 comma 6, B 0 comma 5, and C 3 comma negative 1. So find the vertices of triangle A prime, B prime, C prime after reflection across the x-axis. So remember, just a moment ago I mentioned that the x-axis means that the y changes. The y is going to change from positive to negative or vice versa. So let's write the points. A is negative 2 comma 6. B 0 comma 5. And C is 3 comma negative 1. Then I want to figure out if I just change the y, I get A prime is negative 2 comma negative 6, right? I just changed the y. B prime, again, change the y. 0 comma negative 5. C prime, change the y. 3 comma positive 1. And that is it. And if you don't believe that this truly works, I would get some graph paper, go ahead and plot those points, right? So plot the points A, B, and C, these ones here, and then plot those ones. You'll notice that it is a reflection of each other across the x-axis. So this ends up being our image. Okay, and the last transformation is rotations. We have 3 different types of rotations. We actually have a lot more than that, but they can all be boiled down to just these 3. So I'll mention those. We'll add them also to these notes here. And that if you go all the way around, right, all the way around the circle, or all around the center, we call that 360 degrees. Okay, that one's not really that interesting to us because if you go 360 all the way around, we get the same thing, right? It doesn't change it at all. If we go 90 degrees clockwise, right, we're only going a quarter of the way around. That is also the same as 270 degrees counterclockwise. I'm going to put CCW for that. Okay. Then, so those all have the same rule. And let me talk about that rule really quick. That rule is that we're going to change the x coordinate. Okay, multiplying each x coordinate by 1, -1 means change it. And then you're going to switch the x and y coordinate. So take a look at the rule. X comma y transforms to y comma -x. So the x, you're going to change it. And then you're going to swap or switch those. So the y is going to go first, and then the x is going to go next. Right? Remember to change the x first, though. And then 90 degrees counterclockwise is also the same as 270 degrees clockwise. Okay, so going a quarter of the way counterclockwise is the same as going 3/4 of the way the other way, clockwise. And then lastly, the 180 degrees is the same if we go clockwise or counterclockwise, right? It doesn't really matter. If I go halfway around the circle one way, it's going to be the same as going halfway around the other way. And then the rule, you see that to the right. Okay, so let's try the your turn. Number 4. A triangle has vertices at J, K, and L. What are the coordinates of the vertices of the image after the triangle is rotated 90 degrees counterclockwise? And this 90 degrees counterclockwise is the rule, if you look on the previous page, x comma y transforms to -x comma y. So this means that we're going to take the y, we're going to change it, right? If it's positive, change it to negative. If it's negative, change it to positive. And then we're going to switch those two numbers, right? The x goes last. So let's try it out. J is -2 comma -4. K is 1 comma 5. And L 2 comma 2. Let's transform those. Remember, we're going to change the y. Let me just mark that down. I think rotations are the hardest ones to apply the rule to because there's so much going on. We're going to change the y, and then we're going to switch those numbers. Okay, switch the order of them. So, first one. So the y is right here. Let's change that. Well, if I change -4, it's +4. And then switching them means I'm going to write it first. So 4 comma -2. K prime. Let's change the y. The y is 5. And it's going to become -5 comma 1, right? Switch them. Change only the y. The 1 still stays a 1. And then lastly, L prime is going to be, the y is 2, right? The second number is 2. So that becomes -2. And then the x just goes last. That's still +2. So these are the coordinates of our image. Again, just like I mentioned with the reflection, if you don't believe me that this always works, plot the points of J, K, L, and then do J prime, K prime, L prime. It is a rotation 90 degrees counterclockwise from the pre-image to the image. That is going to be it for this lesson 9.4. Thank you so much for watching, and have a great day.